Okay, just a quick follow-up on the previous video that I posted on graphing polynomials. I wanted to also mention something we've talked about earlier, which is the idea of a function being odd or even. Actually can be very useful to help us get a more detailed graph of a polynomial. So let me give you an example and recall what odd or even is and how you test for it. It's the same starting point. You want to see what happens if you plug in a negative number and see how that compares to plugging in the positive of the same number. So in other words, plug in negative x, f of negative x, in for both of those x's. And of course, any negative number raised to the 6th is just going to be the same as regular positive x to the 6th minus same thing here. That's going to stay the same. And we end up with the exact same function that we started with. So this is an indicator that our function is actually even. And remember what an even function is. Your negative, the values of your negative x values are exactly the same as your positive values. So you get symmetry about the y-axis. Symmetry about the y-axis. So how I can use that, the previous video we talked about graphing polynomials. You would start by finding your x-intercepts. My x-intercepts, if I set y equal to 0 and factor out an x to the 4th, that leaves me with x squared minus 1. And I want to factor this completely. That factors into x plus 1, x minus 1. And I get x-intercepts of from this factor 0, -1, and +1. And on the previous video, we talked about the idea of an x-intercept bouncing off the x-axis or passing through. And remember, it has to do with the power that your 0 comes from. This 0 came from x to the 4th, which is an even power. So this video is, this intercept, this 0 is going to bounce off. I'll just put B for bounce. Whereas both of these, -1 and +1, came from factors to the first power. So these zeros are going to go through. T for through. So how that affects on my graph here. So we have an intercept of 0 and 1 and -1. And what we were discussing is we need to know if our polynomial to the right of 1 is either going to go up towards infinity or down towards -infinity. And the way you can answer that is just pick a test number, something bigger than 1. So if I plug in, say, 2, you can plug that into here if you want to, or you can plug it into the factored form, which is down here, which I think is easier. 2 to the 4th is 16. 2 plus 1 is 3. 2 minus 1 is 1. So I get 16 times 3 times 1, which is 3 times 16 is 48. 48. So it's something big and positive, which means I know that this point is up here. And when I graph it from, let's say from right to left, I know it's going up to infinity. We know this was a through intercept. Now this is where the even, fact that it's even, can be helpful for getting an accurate graph. We know this goes through. And on the previous video, I said, don't worry about how low this goes in between intercepts. It does have to come back around and hit this one. So it doesn't matter so much how much you don't go below the x-axis here. We know this is a bouncing intercept, so it's going to bounce off. And here's where the fact that this is an even function can be useful. Because before that, I said, don't worry about how low it goes. You might have it going way lower than that over here, right? But we know there has to be symmetry about the y-axis. So if you've drawn the right half this way, your left half should look identical or as close to identical as you can get it, so that it resembles an even function. Let's see how that looks for a function like this next one, which is a function made up of odd powers. And you might imagine, well, that's maybe an odd function. So let's test it. if I plug in negative x, a negative number to the 7th is going to come out to be negative. So that would be negative x to the 7th minus 4, a negative number to the 5th is also going to be negative. But if I factor out the negative from both of those terms, I end up with x to the 7th. I'm going to take out whichever negative you want here, either one of these, but I'm still going to be left with a negative. And notice that is the exact opposite of what we started with. This is negative f of x. F of negative x gives you the opposite of f of positive x. So that is the criteria for this being an odd function. And remember, odd function, it's weird. They describe it as symmetry about the origin. We'll talk about that, what that means when we get to the graph here. So let's find our intercepts. So we're going to set this equal to 0. Here it looks like I can factor out an x to the 5th. And that leaves me with x squared minus 4. Factor that completely. That's x plus 2 times x minus 2. And I get x-intercepts of 0, negative 2, positive 2. And notice that all three of those zeros or x-intercepts are coming from factors to odd powers. So these are all going to pass through the x-axis. 0, 2, negative 2. They're all going through here. If I pick a number bigger than 2, I can maybe do that up here. So if I tried f of 3, and I believe I said this on the previous video, when you plug in 3, again, you could either plug it into here, or I find it's easier in the factored form, either here or here. You know, 3 to the 5th is a pretty big number, right? But all I really care about is whether it's positive or negative. I know that if I plug in 3 here, that's going to be a big positive number times 3 plus 5, 3 plus 2 is 5, 3 minus 2 is 1. So I can tell that I'm going to get a big positive number. So that's all that's really important. I know my graph is going up in this direction. It's 3, some kind of positive number, and that's all I really need. So I know it would go up here. We know this is a through intercept, so it's going to come back down. It has to bend back to go through this x-intercept. Remember that if your x-intercept comes from a power that's bigger than an odd power like 3 or 5 or 7, unlike when it's to the first where it just passes through, it actually will bend and get flat like this, just like an x cubed graph. Now, here's where the odd part comes in. Symmetric about the origin means the left side should look like this side if you reflected it over the y-axis and then over the x-axis. Or in other words, you're getting the opposite of all of these y values. So instead of 3 positive, you should end up over here with negative 3, something the very same value, but negative over here. Whatever this point is right here, where we have it as its minimum, is going to be the same over here on the left side. So your graph is going to have that symmetry. And so if it's an odd function, you could get a better idea that this should look symmetrical on the left and right side. And on my homework for my classes, I would want you to do that. I'd want you, if it's an odd or an even function, your graph should reflect that.